I want to take one more look at the assumptions and conditions for using a one mean z interval. And specifically, I want to look at this condition of normal or large. So there's a lot of details here in terms of if the problem states it's normally distributed, or if it's something we know is normally distributed, like heights of people, lengths of fish. Do we make a normal probability plot? Does the central limit theorem apply? Right, so there's lots of ways of going about meeting this condition. And so I want to take a look at how sample size relates to that. So if you have a small sample size that would be considered like less than 15, it has to be normally distributed, or that normal probability plot has to look really pretty straight. It can't have really very much bumpiness in it, and it definitely can't have any curve or anything like that. Okay, if you're in a moderate sample size, say 15 to 30, you have a little more freedom there. So it's usually okay to use this one mean z interval process unless there are outliers where the distribution is far from normal. So if you make that normal probability plot and there's a lot of skew in there, then you're going to run into some issues. But it can be a little bit bumpy and it would still be okay to use this process. And then for a large sample, which we know from the central limit theorem means bigger than 30, it's generally fine to use a one mean z interval without any restrictions. If there are outliers and their removal is not justified, so in other words, it's not a typo or something that we can correct, then what you should do is make the confidence interval with the outliers and without the outliers, and then compare them like on a number line and see what impact those outliers are having on your interval. If it's a huge impact, a substantial impact, you'd want to use a different procedure or take another sample if possible. And then one note about this idea of large. I think people have this idea that large is a fixed number, and for the central limit theorem, it certainly is. It's anything over 30, but typically in statistics, we talk about the size large as being relative to the size of the population. So one rule of thumb is that the population is at least 20 times larger than the sample. So to kind of give you an idea of a ballpark, then that number does change based on how big your population is.